Alright, so this section is 6.2. This is about exponential functions. So I would expect this is not completely new material, but some of it likely will be. Exponential functions. So this is the first family that we're going to look into. So we'll start with a definition. As boring as you could start. Definition. Okay, an exponential function. And we're going to specify by saying of base a. That's lowercase a. Is a function of this form. F of x equals a to the x. Okay, so here a is a real number. X is the variable, of course. A few restrictions. A must be positive for this to make sense. And also, if a happened to be 1, then every output would be 1, and it would be a special case. It would be an oddball case that wouldn't share any of the properties that we're going to talk about, so we throw that out. All right, we're not going to let that come into play. We don't want special cases. So, a couple things. Okay, this is an exponential function, and don't confuse this. Students sometimes do this. Just a little reminder here. I'm going to abbreviate. Polynomial x cubed, my cubic. Okay, so why did I mention this? They look very similar in structure. This is a variable to a real number. This is a real number to the variable. So they flip-flop their roles. So different than a polynomial. Okay. And also I want to mention one other thing. Just like any function, you know, this is, we're saying of this form, this is sort of the vanilla form. We can do transformations just like anything else. Right? I could say, you know, for example, 3, something like this, you know. Right, so we can add these little bells and whistles, but just sort of the pure form is what you see in the box. Okay? Now, we mentioned that the 1 is kind of a value that delineates two sort of types. And what I mean by that is we're going to have properties of these things. Properties. And I'm going to abbreviate exponential here. Okay, 1 is thrown out. If a is greater than 1, you have a list of properties. If a happens to be between 0 and 1, like a fraction, a half, whatever, the properties look different. So we're going to separate sort of the two cases. Now, normally what I would do in a classroom is sort of that old school XY table, you know, make that here, put down some X's and have the students calculate the Y's, plot some points, and see what this thing looks like. Under these circumstances, I'm not going to do that. I'm just going to cut right to the graph. So I want to mention this. We're going to show the graphs of what these look like. And again, there's not going to be a lot of numerical information here because we haven't specified A. It's more about properties, characteristics. And we're going to list them here precisely. But one thing I always emphasize to students is that you can memorize the list. That works. But if you know what the graph looks like, if you have this image, imprinted into your brain, then you understand this list. Okay, so it's, either way. So what I want to do, I'm going to show a curve like this. So a is greater than 1 here. F of x is a to the x. Okay, so a few things. The first property, this is a point that will not change regardless of the base. Why is that? So I'm going to say this is f of 0, of course, my y-intercept. Well, any base to the power of 0, we know what that is. That's 1. Okay, so of course this could be, like I said, transformed up or down, but in this vanilla case, that is my y-intercept. Okay, also, domain. What are the acceptable inputs, right? What is the set of inputs that can be entered into this function? All real numbers. I've almost sketched it. It almost looks like it's almost asymptotic here. It's not. Exponential functions grow at a very rapid rate, so you get steep very quick. And if I go to the actual function itself, and you think about a base like 3, what exponent can I put on 3? I can put anything on 3. Right? So the set of x's is all reals. The range is more interesting. Like I said, this grows without bound. So the right end behavior goes to infinity. And down here, this is asymptotic behavior, right? The x-axis is a horizontal asymptote. So this thing will approach 0 on the y-axis and never reach it. Okay, so effectively the range is all positive values of y, or f of x. Okay, so back to the end behavior. What's these limits? This kind of thing comes up quite a bit. That's an infinity. Okay, so the right end behavior, what is this thing doing in this direction as x goes to infinity? This thing goes to infinity. This thing grows without bound. And then, of course, to the left, this, again, they said this is asymptotic behavior. So as I go to the far left, this goes to 0, which is exactly the definition of a horizontal asymptote. Okay, now this will be the primary focus, and we'll get to the reason why here shortly. But this is your focus. If you have a base, like I said, less than 1, and of course greater than 0, some of this information changes. Effectively, what you're doing is taking this picture and you're going to mirror it over the y-axis. Okay, so it's similar, but of course different. Okay, equals a to the x. Okay, so some of this changes then. Okay, of course this does not change. Have the same y-intercept. Right, that's actually, if you mirror over the y-axis, that point will remain fixed, of course. The domain and range are the same. You can see that. The domain, again, this is a way to write bold R. Bold R, capital R, is a symbol for all real numbers. This is bold enough as it is, but to do this little thing on the end, that represents bold. And then the range is the same too. And really what's different now, as you can see, if I'm flip-flopping this thing over the y-axis, these behaviors are exchanged. Okay, so, and again, you can see this from the graph. So if you remember the picture, you know all of this information. So as x goes to positive infinity, I have asymptotic behavior to the right. As as x goes to negative infinity, this goes to positive infinity. Okay, so this stuff is useful. This will be useful in Calc 3, and of course it'll be useful in this course, right? So let me get a drink. I'm gonna pause quick.